This is Verdict, a forensics agent that doesn't just find evil, it proves it. Nothing here is a slide. Every screen is a real recording of the tool running on genuine evidence, and judged the way this competition asks, can you trace every claim back to the tool call that produced it? A machine gets compromised, and now you have to reconstruct exactly what the attacker did, and prove it well enough to hold up later. By hand, that's days across disk, memory, and logs. Verdict does that grind in minutes and never asks you to take its word. It starts with one line inside Claude Code. Investigate, pointed at evidence, a disk image, a memory capture, an event log, a packet capture. Watch the terminal. The first thing it does is open a case and fingerprint the evidence with a SHA-256, read-only, so the original is never touched. Then it drives real forensic tools, registry, prefetch, event logs, memory, one typed call at a time, each recorded with its own ID. Nothing happens off the books. Now the part that matters most, and the one this competition weighs first. It self-corrects, live, in the terminal, and it does it for real. Here it hits a genuinely broken artifact, a truncated registry hive. The log says, hive truncated, header too small. It doesn't silently retry, and it doesn't fake a result. It writes a named course correction, narrows scope, and moves on to the lanes it can still run. When the failures stack up, a heartbeat check escalates, and it seals an honest, partial verdict over only what it could actually examine. This is an organic failure. Fault injection is zero, not a staged stumble with a suspiciously clean recovery. Feature 1. The verifier. Most agents will happily hand you a confident, wrong answer. Verdict won't let a finding into the report until it's replayed. It has to cite a tool call from this case, and the verifier reruns that call and compares the output hash. If it doesn't match, the finding is downgraded or dropped. Every claim is labeled by how sure it is, confirmed, inferred, or hypothesis. And when it overclaims, it says so. Like the memory process near miss we caught and wrote up. Honesty over perfection. Feature 2. Two investigators, not one. Two pools work the same host from opposite priors. One expects persistence, the other exfiltration. A lone analyst locks onto their first theory. These two argue it out. Every place they clash, detect contradictions logs it as its own record, and a credibility-weighted judge reconciles it on the record. So you see the reasoning, not just a verdict. Feature 3. You watch it work. You're not staring at a spinner. Findings appear the moment they're vetted, each tagged confirmed, inferred, or hypothesis, so you always know how sure it is. The pipeline lights up stage by stage, a timeline assembles itself, and every finding links straight back to the exact tool call behind it. Depth beats breadth here. Every case writes a coverage manifest. Each artifact class marked, passed, failed, unsupported, or not supplied, so partial coverage is never sold as clean. And an execution claim has to corroborate across at least two artifact classes. One deep chain across disk, memory, and logs outscores a dozen shallow log queries. Feature 4. Don't trust it, verify it. Pick any finding. It traces to a tool call ID, to that call's output hash, into a Merkle-rooted, signed manifest. Watch manifest verify pass offline. Now I flip a single byte in the audit log and run it again. It fails, and it names the exact record that broke. The verdict isn't something you have to believe. It's a tamper-evident artifact anyone can recheck, years from now, without trusting us. Feature 5 holds up all the rest. The tool surface. 43 typed tools, 31 in Rust, 12 in Python, and not one of them can run an arbitrary command. No execute shell, no path traversal, every call schema validated, and the bypass attempts live in the test suite. The guardrail here is architectural, built into the types, not a polite instruction in a prompt. Here's how it fits together. Claude Code is the agent. It drives two purpose-built MCP servers, the typed tool surface, which run real forensic tooling inside the SANS SIFT Workstation against a read-only evidence vault. Findings flow through the verifier and the judge into a signed manifest and the analyst report. Each box is a trust boundary, and the guardrails that matter are architectural, enforced by schemas and hashes, not just by asking the model nicely. And it works on real cases. On the NIST Hacking Case disk, it returned suspicious with 8 tool-cited findings. Turned loose on a 22-host enterprise, host by host, it caught 6 machines running the same admin tool at the same second. Lateral movement surfaced as a lead. On a case with a published answer key, it hit 5 of 5 expected findings, a score you can reproduce offline. And when it can't prove something, it scopes down and says so. Clone the repo, run scripts, find evil, and you're in a working investigation in under 5 minutes. Adding a new tool follows one reference file. It's Apache licensed and open. Verdict only ever says 3 things: suspicious, indeterminate, or no evil found in what it examined, and never more than it can back up. Point it at supported evidence and see it for yourself.